All right, so what I was saying is, example. Let's say it's 8/20. All right, what's the greatest number that goes into both the top and the bottom? 4. So you see how I'm not dividing by 8 there, to your question? It doesn't always have to be like that. Okay, a fraction is improper if the numerator is greater than or equal to the denominator. Example. (15/7). Perform the division. You write it as a mixed fraction, 2 and, let's see, 1/7. Okay, mixed fraction. Improper. Sure. How do you turn it into a mixed fraction? Perform the division. Okay, so just like finding the remainder that we did on the test. 15 divided by 7, and say to yourself, how many times does 7 go into 15? 2 times. Now 2 times 7 is 14. Subtract that. You have 1 left over. The remainder is 1. And then it asks you the question, like, what's the dividend, what's the divisor, and all that stuff. You just write a mixed fraction out of that using 2 and 1/7. Okay, good point. Turning improper fractions into mixed fractions. Let's say I wanted to go the other way, as long as we're talking about it. (2 and 1/7) to improper. All right. Multiply the whole number by the denominator. Then add numerator. So 2 times 7 is 14, plus the numerator, and you get back to 15/7. So that's going both ways. Okay. Maybe worth writing down. Question, go ahead. They're the same. That's right. When you're going both ways, if you go from improper to mixed, or the other way, mixed to improper. Denominator stays the same. All right. They give you questions where you have a total number of blocks. Which shaded area, meaning the blue, represents 4 out of 5? A, B, or C? B. This one. All right, so another way we want to think of it is the denominator is like the total. Question so far? Or maybe you want to see another example or something like that.
What if, like, the fraction wasn't in, like, its simplest form, and they asked for that? Like,
In terms of the blocks question? Okay. Yeah, good question. So I'm going to keep shrinking this a little down a little bit. Okay, example. You have 1, 2, 3, 4, 5, 6 shaded blocks out of 10. So which one's the numerator, which one's the denominator? 6 over 10. But just write 6 over 10 and then do what we did before and reduce it. What number goes into both 6 and 10? 2. Divide by 2 on top and bottom. So you see how the rules keep coming back? That would be the answer that they were looking for. Yeah, that's a good question. So the rules keep applying. Do to the top what you do to the bottom when you reduce. Yeah, this is just as I say. The next thing that we usually have an issue with is like number lines and fractions and stuff. So I'm gonna try to show you what it's gonna look like in the homeworks. So let's make this 1, 2, 3, 4. Let's make this 1, 2, 3, 4, 5, 6. The number lines you will see have different numbers of tick marks. Okay? But all that means is that's kind of like what the denominator is going to be. So you see if I count from 0, don't count the 0. Go 1, 2, 3, 4, 5. And the 1 occurs at the 5. So you're breaking up that into 5 equal parts. Yeah. So I love this thing. Close. It's split into fifths, right? So each tick mark would be like 1/5, 2/5, 3/5, 4/5. And then you can write any number 1 as like, you can write it over itself. 5 over 5 is just 1. So if you wanted to plot 3/5, you would say, okay, I know it's broken into fifths, and I go 1, 2, 3. That's where I plot it right there. All right, look at this one now. 3/4. How many tick marks are there between or from the 0 to the 1? 4, so it's broken into fourths. So where would 3/4 be? Yeah, just go 3. Let's do an improper. Another example. How about nine-fourths? Describe where that would be on the number line. And the answer is right after the 2. Because now you're saying, okay, this is the same as writing 4/4. Well, when I get to 2, see it goes 5/4, 6, 7, and 2 is the same as 8/4. Because we all know that 8 divided by 4 is 2. So 9/4 would be right here. Let's do it a third way. I don't know if this will always help you, but how about you take this thing and you do 13 divided by 4? .25. So you say to yourself, okay, it's 3 1/4 of the way. Oh, I got an even better one. I'm on a roll. All right, so we got 2 over. Where would 2 over 7 be located? Two dashes to the right of the 0. Because it's broken into sevenths, right? Where's 4 over 14 located? In the same exact place. It's the same thing. Same rules apply. You got to reduce it.
Will they ask a question 4 over 15, or something like that? Will the denominator be
4 over 15. Okay, so would they give you a different number of tick marks and a different denominator? I have not seen that. No. They, in the computer, they have a dot, and you click on the dot and you drag it. So you click on the dot and you drag, and it goes 1, 2, 3, 4, 5, 6, 7. And that's how you know it's broken into sevenths. Okay. Good question. We'll just do this together. Take about a minute and read through it. The pie chart shows the percentage of students at the college who have 0, 1, 2, or 3 mobile devices. iPad, cell phone, whatever. Question A is, what fraction of the students have 1 device?
Isn't it 80 over 148?
All right, so what's the first step then?
Have to add all of them.
You add them all together to find the total. I got a different total though.
You did?
Yeah. Is that what you got? I got 138. So we're going to add all the numbers together. So for A, we're going to look at 1 device, 80 over 138. Not finished yet though? Let's reduce by, I don't know, 2 is always easy. 138 divided by 2, 169. Okay. Does anything else go into 3? No. That might be it. Not divisible by 2, not divisible by 3, not 5, 6. No. So you'd have to go and check and see if it reduces, but I think that's it. Part B, 3 or more.
8 over.
Do the same thing. So that's 4 over 69. Okay, that's your word problem. Proper fractions can be written as mixed fractions by, we spoke about it already. Yeah, multiplying, right. I really didn't, I just drew a blank. Multiplying, one of those days. the numerator by the denominator. To go the other way, perform division. So it's good practice, I guess. 15 divided by 6. Two times, right? And then 6 times 2 is 12. With 3 left over, the remainder is 3. Try and color code it a little better. The denominator is the divisor. The quotient is the whole number, and the remainder is the numerator. So how about that? And then down here, multiply 8 times 5 is 40. So I get 43 over 5. All right, let's keep going. We'll get about halfway into this. Then we'll be done. In order to reduce a fraction, we can divide the numerator and the denominator separately by a common factor. Doesn't have to be the greatest common factor. Give me a number that goes into both 10 and 5. 5. Good. That's why we do it. We gotta get thinking. You were giving me the answer. All right, good. Common factor of 18 and 10. 2. Write it as a mixed fraction. Can you do it? 1 4/5, exactly right. A common factor of 64 and 16. 64 and 16, common factor. Start small. 4. So take your calculator, you start dividing by numbers, and it turns out that 4 goes into it. Keep going. 16 over 4 is 4. A common factor of 106. 2. What does it become? 50 over 3. The more you practice it, the faster you'll get. How about 21 divided by 3? 7. Right, fractions are also the same as division. A common factor of 80 and 16. 16 goes into it. Any questions up to this point? Comments? Anything?